Welcome to today's lesson. Today we are on lesson 1-6, and for today's learning objective, to identify a geometric sequence. Our language objective is to explain what makes a sequence geometric. So let's take a look at today's do now. Let's take a look at today's do now. What is the pattern in the given sequence? So pause the video and see if you can find the pattern. So for this sequence, the pattern is multiply each term by 2. Let us look at today's thinking. What is a sequence? Recall, a sequence is a list of numbers that is written in a defined order, ascending or descending, following a specific rule. An arithmetic sequence contains a common difference. A series is the sum of the terms in a sequence. A geometric sequence contains a common ratio, r, and the first term is u sub 1. A formula or expression that mathematically describes the pattern of the sequence can be found for the general term u sub n, which is the nth term of the geometric sequence, to be the given formula found in your formula booklet. So let us look at example 1. Example number 1, geometric sequences. Number 1 says find the 10th term of the geometric sequence. So first thing I'm going to do is identify two important pieces. I need to know the first term, and I need to find out what the common ratio of the sequence is. So the first term is -2. And our common ratio is -3, multiplied by -3. So in order for us to find the 10th term, we're going to use the nth term formula. When using this formula, we're going to need to know the first term and the common ratio. All right, so to find the 10th term, we're inputting n to be 10. I'm going to simplify this. The 10th term in this sequence would be 39,366. Let's look at number 2. In a geometric sequence, let u sub 1 equal 3 and r equal 2. Find the first 4 terms and b the 100th term. So for part A, I'm going to list out my 4 terms. We start with 3, and to find the next number, we're going to multiply by the common ratio. So in this case, times 2, times 2, times 2. There's my 4 terms. For part B, we want to find the 100th term, which means that I'm going to use the formula for the nth term. So for this problem, the 100th term, when I input it into my calculator, gave me a number in scientific notation, and I wrote it in correct scientific notation on paper. I also represented my number in terms of two significant figures. Let's look at number 3. For number 3, it says in a geometric sequence, let u sub 1 equal 10 and u sub 10 equal that big number. Find u sub 3. So they gave me two different numbers within the sequence. I am going to start by using a formula I know, which is the nth term. Now, I do know the first term, which is great, but I don't know the common ratio. So what I'm going to do is I'm going to plug in u sub 10. U sub 10 is equal to the first term times my common ratio, 10 minus 1. The reason I am doing this is because I do know what u sub 10 is equal to. So I'm going to use that to help me find r. And I'm going to solve for r by dividing both sides by 10. To get rid of that exponent of 9, I'm going to root it, 9th root. I put this into my calculator and I get a value of 3. Now that I have the value of my common ratio, I could use the nth term formula again to help me find u sub 3. And u sub 3 is equal to 90. Let's look at our next problem, number 4. A geometric sequence has a fifth term of 3 and a seventh term of 0.75. Find A, the first term, u sub 1, and the common ratio r. B, the 10th term. Alright, so let's start with part A. I want to find the first term and the common ratio. So I'm going to write down the formula I know. But as this formula is currently written, it's not going to be useful at all for me. So I'm going to manipulate it slightly. If this is the nth term formula, I can manipulate the nth term formula to help me find what we are looking for given our information. So I can manipulate the first term to be u sub 2. R, in this case, my exponent would be n minus 2. Or I could keep going. I could start off with my third term, common ratio n minus 3. Start off with my fourth term, common ratio n minus 4. And this pattern will continue. So why is this helpful? Because they gave me my fifth term and my seventh term. So I know u sub 5 is equal to 3, and I know u sub 7 is equal to 0.75, which means that I am going to use this formula to find my common ratio. Now, one little thing is that I'm going to make n equal to 7, and you will see why right now. If I make my n equal 7, that means that I know what u sub 7 is equal to. So I'm going to replace that value. And let me think about this. This exponent here is telling us that in order for me to go from the fifth term to the seventh term, I am multiplying the common ratio 2 times. So it does make sense. At this point, all we have to do is just solve for r. So I found the common ratio to be 0.5. Now that I have that, I am going to find the first term. Still sticking to the formula. This time finding the first term. And we get that the first term in this sequence was 48. For part B, now that I have the first term, the common ratio, I can use the original formula to find the 10th term. And my 10th term is equal to 0.09375. Let's look at our last problem here. Find the 7th term of the geometric sequence shown below. So first thing I'm going to identify is the common ratio. Looking at the sequence, the common ratio is negative 2x to the fifth. Our first term is negative 6x to the fifth. So we want to find the 7th term. We're going to use the nth term formula, plug in what we know, and find the 7th term. All right, there's my substitution. I'm going to simplify. I'm going to apply laws of exponents. At this point, I'm going to multiply my coefficients together and add those given exponents, again using the laws of exponents here. And my 7th term is equal to negative 384 x to the 35th power. So keep learning, keep growing, and I will see you in our next video.